So welcome back, grade 10s. We are now going to have a look at some of our common factor types of exponential equations. These are slightly more challenging than the ones that we've done before, but they are by no means impossible. So let's dive straight into it and learn exactly how we can deal with some of these problems. So just a quick note, we are often going to be splitting the powers using the first exponent law, but in reverse. So it's something we have done before, right, in a previous video, but now we are applying that same technique to our equations. So let's have a look here. First things first, I am identifying that yes, I am dealing with an equation that involves exponents which contain my variables, okay? So immediately my mind is going to go to the methodology in which I'm about to show you, okay? So, step one, we need to split our exponents up, okay? And once we split our exponents up, we are going to factorize, okay? So we're going to split and factorize. All right, so let's start by doing that. Our reverse law is basically telling us that this is going to become 3 to the power of x multiplied by 3 squared minus 3 to the power of x, which is now equal to 72. Once I have split this, I notice that I have a common factor I can take out. So I'm going to take out my 3 to the power of x, and what I'm left with is 3 squared minus 1. That is equal to 72, okay? So I've split, I've factorized, okay? Now I want to start simplifying, okay? So now we're going to simplify. What I mean by simplify is we are going to take over any of the constants we can to the other side, and then we just apply our usual method, okay? Make the bases the same, drop the base, solve for x. So this becomes 3 to the power of x. 3 squared is 9, minus 1 is 8, and that is equal to 72. I'm going to take this 8 over to the other side, all right? I'm currently simplifying, okay? And what I end up with is 3 to the power of x is equal to 72 over 8, all right? 72 divided by 8 is equal to 9. Okay, and I'm happy to see that 9 now, because we know that we need to get the bases the same, and this 9 is simply a 3 squared. So I get 3 to the power of x is equal to 3 squared. I have got my bases to be the same, so I can cancel and drop my bases down, and I find that x is equal to 2. Remember here that you can check your answer. You can take this this x equals 2, plug it into your 3 to the power of x plus 2. So you're going to replace this x with a 2, replace this x with a 2, and your answer, if you type it in your calculator, should come out to be 72. That is how you check that you are correct. Okay, let's try another one. So immediately I'm seeing, okay, I have a 3, I've got this 5x, I've got another 5x, but I need to split it up first, and that is all equal to 40. So let's begin. 3 multiplied by 5 to the power of x plus, and here comes the split, 5 to the power of x multiplied by 5 to the power of 1 is equal to 40. Okay, I notice now that I have a common factor I can take out, so I'm going to take this 5 to the power of x out. That becomes 3 plus 5 to the power of 1, which is just 5, is equal to 40. Now, I can take this 3 plus 5, it's going to become an 8. So let's just do this step by step. It's equal to 40. I'm going to take over this 8 to the other side. It is being multiplied on this side, which means we divide on the other side. So I get 5 to the power of x is equal to 40 over 8. And I'm happy to see this because 40 over 8 is simply 5. This 5 over here, you can imagine it as being 5 to the power of 1. Okay, so when we drop these bases, because they are the same, we find that x is equal to 1. Okay? Next up, I see that I have a 2 to the power of 2x. 2 is a prime number. I see I have a 4, which can be converted into 2 squared, okay, is equal to 12. So I'm going to start with that, right? We're not going to jump the gun. Whenever we start, we want to just try our best to make the bases the same and write down that step, okay? Write down a step by step. There's no point in jumping the gun here. This is going to multiply into both of these. Be very, very careful. This becomes 2 to the power of x minus 1, okay? And this 2 is going to multiply in, and it's going to give us 2x minus 2. A lot of the time, you guys are just writing 2x minus 1. Be very, very careful of that. Okay, so let's do that quickly. So we have 2 to the power of 2x minus 2 to the power of 2x minus 2 is equal to 12. Now, I cannot make this 12 with the base 2, but I can split this up and factorize. So let's give that a go. I have 2 to the power of 2x minus 2 to the power of 2x multiplied by 2 to the power of negative 2, which is equal to 12. I'm going to take out this common factor over here. What I find is 2 to the power of 2x, 1 minus 2 to the power of negative 2 is equal to 12. Now you can use your calculator here, okay, and I recommend using your calculator because it can get a little bit tricky. This is 2 to the power of 2x. Now this is 1 minus 2 to the power of 2, or 1 over 2 to the power of 2, which is 1 over 4. Okay? So 1 minus 1 over 4 will leave me with 3 over 4. If you struggle with these types of calculations out of your head, just use your calculator. And even if you're very good at doing this kind of subtraction of fractions, I recommend just using a calculator anyway, because sometimes we make some mistakes on the way, okay? So what I'm going to do now is I'm going to actually take this 3 over 4 and I'm going to bring it over to the other side. Okay, and what happens is when I bring this over to the other side, it gets inversed and becomes 4 over 3. Okay, it becomes 4 over 3. So I get 2 to the power of 2x is equal to 12 multiplied by 4 over 3. Okay, and now this 12 is going to multiply in with this 4. So I get 2 to the power of 2x. 12 times 4 is 48. 48 divided by 3. So I have 2 to the power of 2x equals 48 divided by 3 is 16. 32, 16. Okay. So we have 2 to the power of 2x equals 16. And I'm happy to see that 16 again, because I know 16 is going to become 2 to the power of 4. Okay, so if that becomes 2 to the power of 4, we are then going to be able to drop these bases. Okay, I'm skipping a step here quickly because I'm running out of space. We get 2x is equal to 4, and therefore x, we're going to divide both sides by 2. So x is equal to 2. There you have it. So nice, very nice question here. Very, very nice with this fraction in the middle over here. Okay. Let's do another one. So we've got 3 to the power of x plus 1 minus 2 times 3 to the power of x minus 1 is equal to 21. Now immediately I am seeing that, hey, I've got a base 2 and a base 3 in this equation. Okay, so we need to figure out how we're going to deal with that. I am going to start by splitting up my exponents and taking out a common factor. So 3 to the power of x multiplied by 3 to the power of 1 minus 2 times 3 to the power of x multiplied by 3 to the power of negative 1 is equal to 21. I'm then going to take out my common factor. So I'm taking 3 to the power of x out. That leaves me with 3 minus 2 times 3 to the power of negative 1, which is equal to 21. Now we need to start simplifying. Again, what you can do is use your calculator over here. If you use your calculator to calculate this and you get a decimal place number, what you can do is just press the SD button and it should flip it back into a fraction if that's the case. But we're going to try and work this out without a calculator quickly. So this is 3 minus 2 over 3 equals 21. Okay, remember this 3 to the power of negative 1 over here. We can take it down into the denominator. That just means 2 over 3. Okay? So we get 3 to the power of x multiplied by, now 3 minus 2/3, okay, is going to leave me with 2 and a third. 2 and a third, 2 times 3, so that is 7 over 3, which is equal to 21. And just as before, I'm going to take the 7 over 3 over to this side, and when you do that, it actually becomes inversed. Remember, this equal sign is like a wormhole. It inverses everything when you bring things over it, okay? That's the way I at least like to look at it. So this is now 21, okay, multiplied by 3 over 7. All right, so we have 3 to the power of x is equal to, this is 21 multiplied by 3 gives me 63. 63 over 7. 63 over 7 is going to equal 9. So we have 3 to the power of x equals 9. And I'm happy to see that again, because this 9 can be brought down to a base 3. It is 3 squared, and therefore we find x is equal to 2. Because these two bases are the same, we can very simply drop our base, and that will give us our final answer. Very, very nice question. All right, and we'll do another one. Over here, I am seeing that we have 3 terms, right? We have these 3 terms, which are separated by our plus and minus signs. They're all at the base 3, which is great to see. It is all equal to 21. So I am going to start by splitting these two up and working it from there. So I have 3 to the power of x multiplied by 3 to the power of negative 1 minus 3 to the power of x plus 3 to the power of x multiplied by 3 to the power of 1, which equals 21. Okay, same as before, we are looking for a common factor we can take out. In every case, it's going to be your base with your exponent that contains your variable. So you can see it's a recurring theme over here. Okay, so 3 to the power of x. What am I left over with? I'm left over with 3 to the power of negative 1. We're going to have a 1 as a placeholder here, and we're going to have 3 to the power of 1 over here. Notice how 1 is my placeholder because when I multiply this back in, I should always get back to my original expression, which has 3 terms. What that means is that if I have 3 terms and I factorize, I have to have 3 terms in my brackets after I take out that common factor. Okay, so let us start to simplify a bit. This is 3 to the power of x. All right, what am I left over with? This is a third minus 1 plus 3. Minus 1 plus 3 just gives me a positive 2. So this is plus 2 equals 21. Okay. If I turn this into an improper fraction, I have 2 and a third. Okay. You can write this as 2 and a third like this. That's actually what it means. But the way I like to do this, just to show you very quickly, if I want to turn this into an improper fraction, what I'm going to do is I'm going to take this 2 multiplied by the 3, okay, whoops, multiplied by the 3, and then add it to the 1. So 2 times 3 is 6, plus 1 is 7. So it's 7 over 3. That is equal to 21. Okay, then I have 3 to the power of x. I'm going to take this over to the other side where it becomes inversed. So I get 21 multiplied by 3 over 7. Okay, and I feel like we've just had this one. 21 times 3 is 63 over 7. Again, that's a 9. 9 is very simply 3 squared. We're going to drop our base now, and we get x equals 2. And there you have it. Very, very nice. And last but not least, one that looks very tricky. It kind of looks like it's a quadratic equation or a trinomial, right? Because I'm seeing this 2, this 1, and then this absence of a variable. But what we're going to do is we're just going to chip away at the block and use the same techniques we've been using the whole time. Okay, so I'm seeing this exponent has a variable. Okay, this negative 12 is sitting over here, but usually we don't have it sitting over here. I'm trying to get to the m in this case, so I'm thinking I'm just going to bring that over to the other side. What else I'm seeing here is this 9, which I know this 9 is going to become 3 squared. So let's start with that. I have 3 to the power of 2m minus 1 plus 3 squared. I'm just going to put it in brackets, m minus 1. Now I'm putting in brackets again because this 2 is going to come in and multiply into both of those, okay? And I am going to bring the 12 over to the other side because that format is what I'm used to performing, okay? Let's see what we get. So we get 3 to the power of 2m minus 1 plus 3 to the power of 2m minus 2, which is equal to 12, okay? Now I'm going to do a split. So I'm going to split these apart. I get 3 to the power of 2m multiplied by 3 to the power of negative 1 plus 3 to the power of 2m multiplied by 3 to the power of negative 2, which equals 12. Is there a common factor I can take out? Yes, there is. So I'm going to take out my 3 to the power of 2m. What I end up with is 3 to the power of negative 1 plus 3 to the power of negative 2, which equals 12. All right? Use your calculator over here if you must. I don't have a calculator with me, so I'm just going to do it manually. This becomes 1 over 3. This is 1 over 3 squared, which is 1 over 9, which equals 12. If I make the denominators the same, I'm going to multiply by 3, multiply by 3. So both the denominators are 9. Then I'm going to add them together. What happens when I do that is I get 3 plus 1, which is 4, over the common denominator of 9, which equals 12. And now I'm going to take that 4 over 9, I'm going to bring it over to the other side. It's going to become inversed. So I get 3 to the power of 2m is equal to 12 multiplied by 9 over 4. Okay, and now this 12 is going to multiply into the 9. So I get 3 to the power of 2m. 12 times 9 is 90 plus 18, which is 108, if I'm not mistaken, over 4. So 3 to the power of 2m, 108 divided by 4 is going to be 25 plus 2, which is 27. Love to see that, okay, because 27 can become 3 to the power of 3. So I get 3 to the power of 2m equals 3 to the power of 3. And now I can drop my base. And what I get is 2m equals 3. And we're going to divide both sides by 2. And I get 3 over 2. Okay? Interesting to see that we ended with a fraction here. But it's not uncommon to end with fractions. And normally what we do is we just keep them as an improper fraction. Okay? So there you have it. If you must, you can take this okay? And you can go and plug it back into your original equation. So we'll plug it into this m, we'll plug it into this m, see what answer you get. Let me know in the comments if I made a mistake, because I'm just doing this without a calculator, but there you have it, a very nice one there at the end. Complicated, but not impossible as long as we are following the correct steps. So thank you very much. I hope this video helps, and good luck with all of your upcoming assessments. Cheers.